So before we address the question of what the potential energy is, let's just take a moment and imagine what's going to happen when we release this charge q. Well, if this charge is positive, it's going to accelerate in this direction. And if this particle accelerates, it's going to gain kinetic energy. And we know from Unit 4 that the change in kinetic energy of the particle is equal to the work done on the particle. And what's this work equal to? Well, the work is just the force that the electric field is applying on the charge over the distance it's being applied over. This means that if the charge moves all the way over to the negative plate, then the work done by the field will equal the force applied by the field times that distance x. And what's this force equal to? Well, we know that's just equal to the electric field strength times the charge of the particle. Alright, so putting this together, we've found that the change in kinetic energy is equal to the electric field strength times the charge of the particle times the distance it moves through x. Alright, now let's use conservation of energy to relate this change in kinetic energy to a change in potential energy. So in this case, because there aren't any extra forces doing any work on the charge, only the field is doing the work, we know that the change in kinetic energy is in fact exactly equal to the change in potential energy. And the change in potential energy is just equal to the difference between the original potential energy and the final potential energy. And we know that if the charge moves all the way to the negative plate, it has zero potential energy, so we can cancel out this term, which leaves us that the change in kinetic energy is exactly equal to the original potential energy. And we know that the change in kinetic energy is equal to EQX, so this gives us that the original potential energy was equal to EQX. So this is our nice formula for the potential energy of a charge in a constant electric field. And you might notice something really cool about this. This formula is actually effectively the same as our gravitational formula, mgh. In this equation, the gravitational field strength is replaced with the electric field strength, and the mass of the particle is replaced with the charge of the particle, and the distance away from the negative plate is essentially the same as the height above the ground. So what we've seen here is that this formula is completely analogous to our gravitational potential energy formula, which is awesome. Alright, if you were able to get this equation, great job.